Hello and welcome back. Today we are going to start our new section in which we learn about the object-oriented programming. Now, Java is a object-oriented programming. Object-oriented programming is a programming based on the concept of objects, which may contains data. So let's understand this theory with the help of an example. Now here, a dog has states, color, name, breed, as well as some behaviors. Now imagine that there is a dog. It can bark, it can walk, it can eat, it can drink, etc. There is a dog which is a class, and when a new dog baby born, then that baby dog is the object that has all the features of a dog. In the same way, what is class? Class is a blueprint that describes the behavior. An object has states and the behaviors. Now, states and the behaviors of the object are defined in the class. In the real world, a baby dog has states and behaviors which are described in his mother. So you can understand this relation classes and object by using the real world example dog and his baby. Now dog is the class and his baby is the object. I hope you understand the relationship of class and the object. Now what are the states here? The states is color, name and breed. Now these states are the instance variable in a class, and what are the behaviors? Behaviors are the instance functions in a class. You can better understand it when we will write our code for our class. So let's create our code for a class in NetBeans. So here first of all I add my package, that is package student. My file of Java is present in the package of student. Then I create a class. A class is created by using the class keyword. I type here public, then I type the class keyword, then I have to type the name of the class. For this video I type here student, and this is the body of the class. Now here I have to describe some states, like I type here string name. A student must have a name, int roll number, he has a roll number, and double CGPA. Okay, so these three things are the states of this class, and also you can say that these three are the instance variables and the member variables of this class. Now we have to describe some behavior of these variables, what these variables are going to do. So I create a member function here. I type here void, and the name of the function will be student name, and in the body of the function I type the single statement system dot out dot println the name of student. I create one more instance function here, void student fee, and type your system dot out dot println the roll number of student. Now here I am going to create the main function. I type here public static void main and string args, and within the body of the main function I am going to create an object of class student. So how I can create the object of class student? First of all, I have to type the name of the class student. Then I have to type the name of the object. I type here s1 as the name of object and type the new, and then again I have to type the student class name. And in this way we can create object of class. So we have created the object of class student. Now I am going to call the instance member functions of the class. I type here s1, put the dot operator and call the student fee. Again s1 dot student name. Now if I run this program, you will see two lines on the screen: the roll number of student, the name of student. Now here these three are the states of this class, or you can say these are the instance variable of this class, and these two functions or methods are describing the behavior that what we are going to do in this class. This is just simple function, it is going to print this line, but when we create our next programs, then we are going to type a proper code in the functions that describe the behavior, proper behavior. So this is just an example of the class, and how we can create a class and how we can create object of that class. I hope you understand about the classes and the objects. Now I explain it again with the help of the real world example. Now dog. Dog is the class and his baby is the object. Whenever a new baby is born, it is called the object of the class dog, because that object has all the functionalities of the class dog. So this is what we call classes and objects. If you feel any problem while understanding it, you can definitely ask me a question. And that's it for this video. I will see you in next video. Hello and welcome back to this course. Today in this video we are going to discuss about the second part of the class. Now the first thing that you may got a question that why we don't write here private or protected. Why we only write here public. Now if we make it private, then it is completely useless because nothing would have access to it. And so that's why we don't use private, because nothing can access this class and we don't want to do it. And the second thing, why we don't make it protected. If we are allowed to make a class protected, then we can access it inside the package very easily. But for accessing that class outside of the package, we first need to extend the entity in which this class is defined, which is its package. And since a package cannot be extended, defining a class protected will be again making it package private, which is similar to defining it as default. So there is no benefit of making this class protected. I hope you understand why we don't use private and why we don't use protected, because we have no longer access to this class. And the second thing which I want to discuss in this video about the variables. Now these variables here are called the instance variables. And if I declare a variable inside the body of the function like int a, now this variable is local variable, because this variable can only be accessed inside this function. It cannot be accessed outside the body of this function. And the third variable is called the class variable. When we create a variable using static keyword like static int phi, then this is a class variable. And we will discuss about this static keyword soon in this section. So these are the three variables that we have in class: the instance variables, that are the just variables of the class, and the second is class variables, which are created by using the static keyword, and the third one is local variable, which are created or declared inside the function of that class. So you must know about these things. And one more thing, you can also initialize this variable like int name equals to, you can type here Java, and you can also concatenate here name, concatenation name, and when you run this program you will see name equals to Java. But this is not the best way to initialize the variable. We will use constructor to initialize our variables. We will discuss about constructor in our next video. So I think you understand. Now one more thing for OOP, that OOP has 4 pillars: polymorphism, inheritance, encapsulation and abstraction. We will discuss about all these pillars in our next videos. So I think you understand about the classes and the objects, and now you are able to create classes and objects by your own. So in our next video we are going to discuss about the constructors, and we are also going to create a proper class and objects. So that's it for this video. I will see you in next video. Hello and welcome back to this course. Today in this video we will discuss about the access modifiers in Java. So what are access modifiers? Access modifiers in Java helps to restrict the scope of the class, constructor, variable, method or data member. There are 4 access modifiers available in Java. Default, no keyword required. Default means we have to type nothing. Private, protected and public are 3 keywords. Now these are the 4 access modifiers in Java, and these are help us to restrict the scope of the class, constructor, variable or any member. So first of all, let's see what is default access modifier. So when no access modifier is specified for the class, method or data member, it is said to have a default access modifier by default. The data member, class or methods which are not declared using any access modifiers having default access modifier are accessible only within a same package. Now when you type nothing with the class name, method or any member, then that member is considered have a default access modifier, and in default access modifier the members can only be accessed in this same package. If you use the default access modifier, then we can use that member in the same package classes. So this is the default access modifier. Next we have the private access modifier. This private access modifier is specified using the keyword private. The methods or the data members declared as private are accessible only within the class in which they are declared. Any other class of the same package will not be able to access these members. Now the private access modifier is written using the private keyword. We type the private keyword before the function declaration or class or any member of that class, and when we declare something private, that it can only be accessible within the class. We cannot access that member outside that class. We make our member private. So this is the private access modifier. We can only use that member in the same class. This modifier is very important whenever we want to hide our data from the user. We use the private access modifier because we don't want to show any information to the others. So that's why we use the private access modifier. Next we have the third access modifier, which is the protected. The protected access modifier is specified using the keyword protected. The methods or the data members are declared as protected are accessible within the same package or subclasses in different packages. So this is the protected access modifier, which is written by using the protected keyword. So whenever we declare some class, method or data member as protected, then that method, class or member can only be accessed in the same package. But if there is a child class in the other package, then we can access only that subclass from other packages. Otherwise we cannot access any class from the other packages. This is the difference between the default and the protected. In default we can only access the member within a package, but in protected we can access the members within a package, but also we can access the subclasses through the inheritance. We can access that subclasses using the protected access modifier. At the last we have the public access modifier. The public access modifier is specified using the keyword public. This public access modifier has the widest scope among all the access modifiers. Classes, methods or data members which are declared as private are accessible from everywhere in the program. There is no restriction on the scope of the public data members. Now public access modifier is written by using the public keyword, and this modifier has the widest scope among all the access modifiers. When you declare any class, method or any member as public, then that member, class or function can be accessed from anywhere. You can access that member within a class, you can access that member within a package, you can also access that member outside the other package. So when we use the public access modifier, we can use that member anywhere we want. There is no restriction of the scope of the public data members. So these are the 4 access modifiers in Java that help us to make our program more efficient. So let's create a simple program in our NetBeans to see that how we can use the access modifiers. So here first of all in NetBeans you can see that with the outer class we have a class with the public. It means that we can access this class from everywhere, and this is a method which is also public. We can also access this method from anywhere. Now if I just remove this comment from here and I create a class here, first of all class example. Okay, now if I create a method here, for example void fun, and in here I type system.out.println and I type here function for an example. Okay, so now if I just create the object of the example class here, example is equal to new example, and I call the e dot fun. Definitely we can call the fun method because it has default access in that class. Default access means we can access that class in the same package. But if I make this public, definitely we can access that because public member can be accessed anywhere. But if I type here protected like this, then definitely we can access that function here because it is present in the same package. But if I type here private, now I got the error. Fun has private access in example means this function can only be accessed inside the example class. We cannot access this method outside this example class. So this is what we call the private access modifier. So in this way we use the access modifier. We have 4: default, public, private and protected. I have given you a detailed lecture that how these works. So I hope that you understand. I repeat it once again. Any member which is the class, function or any member has public access modifier can be accessed from everywhere. The protected access modifier can be accessed within a package, and also we can access the child classes that are present in the other packages using the protected access modifier. But when we use the private access modifier, we can only access that member in the same class. We cannot access that member outside that class. Like you can see here, the fun method is private there, so I cannot access that in my main method. Fourth one is default. When we declare something default, means we pass nothing. We just type here void fun, that is has default access modifier, and that function or member can be accessed within the same package. So these are the 4 access modifiers that we use to make our program more robust. So I hope that you understand. Now one thing that you have to keep in your mind, that there is only one public class in one file. You can see here access specifier is a public class and the name of this file is also access specifier. We can have only one public class in one file, but we can create many classes as we want without the public. Also, the outer class only be public or default. We cannot write here private or protected. With the outer class, we can only write the public or default. So this is the public class and this is the default class. This means that we can create one public class and many classes that has default access modifier. So this is the point that you have to keep in your mind. So I hope that you understand. So anyhow, if you feel any problem by understanding the access modifiers, you can definitely ask me a question. I am always here to help you. So that's it for this video. I will see you in next video. Hello and welcome back to this course. Today in this video we are going to learn about the constructor. A constructor initializes an object when it is created. It has same name as its class and is syntactically similar to a method. Constructor has no explicit return type. We use a constructor to give initial values to the instance variable defined by a class. Now constructor is the very first thing that is executed when we create an object of that class. Now the constructor has the same name as the name of the class and has no return type. Now constructor only initializes the instance variable in the class. I hope you know about the instance variables as we have discussed about the variables in our previous video. So let's create a constructor in our NetBeans. So here I am going to create a class of student. I type here public class student. So here I am going to create the instance variable. I type here string name. And this time I am going to create these variables private. Why I have created this instance variable private, I will let you know when we will discuss about the abstraction. So I am going to create another variable private int roll number and private int fee. I have created 3 instance variables. Now I am going to create the constructor. I type here student, as we know that the constructor name is just the name of the class. So constructor, and in the body of the constructor I am going to type name equals to Java and roll number equals to 300 and fee equals to 10,000. And now I am going to create the instance member functions of this class. So I type here string get name and I return name and int get roll number and return roll number, and the third one is int get fee and I return fee here. Now I have created a constructor and I initialize my instance variables using a constructor. Now I am going to create the main function. I type here public static void main string args, and within the body of the main function I am going to create an object of class student. So I type here student s1 equals to new student. Type here s1 dot get fee, s1 dot get name, and s1 dot get roll number. And it is going to, when I run this program, you will see nothing on the screen because these functions are now returning the value. So I have to print this value. So I type here system.out.println and I am going to print the value which this function is going to return. So now if I run this program, you will see 10,000 Java and 300 on this screen. Where these values come from? These values come from this constructor. Whenever we create an object of the class, the first thing that is executed is the constructor of that class. So when the constructor is called by the compiler, name is initialized with Java, roll number is initialized with 300 and fees is initialized with 10,000. And when we return these values, we get these values on our screen. You can make the parameterized constructor also. So you can also create more than one constructor in your class. I am going to create another constructor here. I type here student, and this time this constructor will be parameterized constructor. So I type here string n int r and int fee, and name equals to n, roll number equals to r, fee equal to f. And now when we create the object of this class, I am going to pass the values here. I pass here John and 200 and fees will be 5,000. And now if I run this program, you will see 5,000 John and 200 is printed on the screen. Why? Because this time we call this constructor, parameterized constructor. When we pass these values, the compiler automatically choose the best constructor, that is this parameterized constructor. If I copy this code from here and going to paste it here, I pass nothing here, and change it to S2. And now if I run this program, you can see that at first we got these three values, 500,000, John and 200, which we pass to the constructor. And second time when we pass nothing in the constructor, the compiler automatically use our non-parameterized constructor that has these values. So you can create parameterized constructor and also non-parameterized constructor. Now what will happen if we only know about the two values? Now you can also create another constructor. Now I am going to create another constructor here, student. This time this constructor only take one argument, or you can say it has only one parameter. So I type here string n and name equals to n, roll number equals to 100 and fee equals to 1000. So you can also create a constructor that takes only one argument. Now if I copy this code once again and paste it here and change from S2 to S3, and now this time I pass only one parameter here. I type here quiz and run this program. You will see the first three values are the values that we have passed to the constructor number 3, to this. And second time when we pass nothing, then the compiler takes the first constructor, that is non-parameterized constructor. And the third time when we pass only one argument, that it takes the third constructor, that is this, that takes only one argument. So I hope you understand what is constructor and why we use it. We use constructor to initialize the instance variables of that class. You can create more than one constructor in a class. The constructor may be parameterized or non-parameterized. That totally depends upon you. Now you may got a question that if you don't create any constructor in the class, then what will be happen? Now if you don't write any constructor in the class, then the Java automatically create a constructor for you. Now how that constructor look like? That constructor would be like this, student. Now this is the default constructor which is created when we don't create any constructor. But when we create constructor, then this constructor is not going to execute, because Java is going to take only other constructors. So I hope you understand about the constructors in Java. If you feel any problem, then you can definitely ask me a question. That's it for this video. I will see you in next video. Hello and welcome back to this video. Today in this video we are going to discuss about the constructor chaining. Now without doing anything, I am going to create a code so that you can understand it in better way, that what is constructor chaining. For this I am going to create a class here with the name class A. And in this class I am going to create a constructor. I type here A, and in this constructor I type a statement system.out.println constructor of class A. Now I am going to create another class with the name class B that extends A. And here I am going to create the constructor for class B. So I type here B, and in the body of the constructor I type system.out.println constructor of class B. Okay, so here I am going to create the main function here, public static void main and string args. And in the body of the main function I am going to create an object of class B. So I type here b1 equals to new B. So let's run this program, and you see two messages on this screen, constructor of class A and constructor of class B. Now how it's happened? We have only created the object of the class B. So why we get the constructor of class A here? This is what we call the constructor chaining. Let's understand it. When you extend a class or you create a child class of another class creates a constructor, then by default Java add one statement here, that is super. This means that call the super class constructor first and then run the child class constructor. Now if I run this program, you will see same message on the screen. We can also write this statement by our own, but Java by default creates this statement here. Now keep in your mind that you can only write super and this here. Now you don't write super and this at the same time. You can only write super at one time, or you can write this at a single time. Let's make this program more tricky. I am going to create one more constructor here. Definitely this constructor is going to be parameterized. I type here B, and in the parameter I pass A, int A. I am going to type another statement here, system.out.println, and I type here constructor of class B, constructor 2 of class B. This is the second constructor of the class. Rather than typing here super, I type here this and pass any integer here. What does this mean? This means that they call the constructor of the same class that have one parameter, like this. And now if I run this program, you will see three messages on the screen. First of all, constructor of class A, constructor 2 of class B, and constructor of class B. This time we don't have write super here, and we only write this here. Why we are getting constructor of class A here? What is the reason? The reason, when control come to this constructor, when the compiler want to execute this statement, control moves toward this constructor here. Now when it comes here, there is a by default statement here that is super, because Java automatically writes super here. So what is the super class of this? The super class of this constructor, the super class is this time class A. So first it calls the constructor of the super class, and then it prints this statement, and then it go back and print these statements in a sequence. So this is the constructor chaining. The constructor are chained with each other. I hope you understand about the constructor chaining. I repeat it once again. When you create child class of another class and creates a constructor, then when you create object of the child class, the Java automatically executes the constructor of the parent class by writing here super. But we can also write here this by our own if we want to execute the constructor of the same class like we have done before. Now also keep in your mind that you can only write super and this, but we don't write super and this at the same time. At one time you can only write super or this. That's totally depends upon you, and that's also depend upon the scenario of that program. I hope you understand about the constructor chaining. So that's it for this video. I will see you in next video. Hello and welcome back to this course. Today in this video we are going to compare object with instance and object with the reference. So first of all we compare reference with the object. Now how you can create a reference? When you put your class name and after that you type the reference variable like here I have write the E, then this is called creating a reference. And when you want to create an object, you use the new operator like employee, where employee is the reference and is equal to new employee and parentheses and then semicolon, and this whole creates an object for you. This is what we call create a reference and an object. Now you can see it in a graphical view that when we create only reference, then the top one, which is S1, is just a reference, not an object. This is a reference. And in the below figure, you can see that the S1 reference is pointing to the object that has some instance variables like name, age, and CGPA. So this is the difference between the reference and an object. Reference just create a reference variable that points nothing. But when we create an object, then the reference points to the object that we have created. Like you can see in this presentation, that S1 is pointing to the object of class student. Now let's compare instance with the object. Real world objects has two main characteristics, state and behavior. For example, a car, which the object has state, speed and gear, and has states apply brake and change gear. In Java, an object stores its states in fields, or you can say store its states in instance variables, and exposes its behavior through the methods. This is the object. Now what is the instance? An instance is a unique copy of class that represents an object. When a new instance of a class is created, JVM will allocate memory for that class instance. This is what we call the instance. Now what is the major difference? An object represents states and behaviors of a class, and an instance is a copy of class that represents the object. So this is what we call the instance and the object. Many of the people take object and instance as the same thing, but there is a little bit difference between them. That is, object represents the state and behavior of the class, and instance is the copy of the class that represents an object. Let's discuss an example that will help us to understand object and the instance. Let's suppose we have a class that represents an employee with the fields like name, age, and salary, which are the instance variables or class members. Now there are three employees, John, Peter, and Bob. So there are three instances of the class. We have created three instances of the class that represents the object. Now what is the object? Object represents the state and the behavior. Objects only represents the instance members and instance functions of the class. I hope you understand what is instance and what is an object. So this is the video that will help you to clear your concepts about the reference, object, and instance. I hope you understand, and that's it for this video. I will see you in next video. Hello and welcome back to this course. Today in this video we are going to discuss about the encapsulation. Encapsulation is the pillar of the OOP, and encapsulation in Java is a mechanism of wrapping variables and codes acting on the data together as a single unit. Encapsulation means we create some instance variables and the member functions, and when we wrap up in a single unit, then that thing is called the encapsulation. It leads to data hiding, but not data hiding. It is also a way of restricting access to the certain properties of the component. Now data hiding means that we make our members private so that no one can access them. So encapsulation can be achieved by making member variables private and by creating getters and setters public, so that we can access the values of the member variables that we have made the private. Now what are the benefits of the encapsulation? With encapsulation, the fields of the class can be made read-only or write-only. How we can do that, we will discuss about it in our NetBeans definitely. And a class have a total control over what is stored in the fields. These are the two benefits of the encapsulation. So let's create a program to implement the encapsulation in Java. So first of all, here I am going to create a class with the name, you can say student. And now in this slide we have read that we can achieve the encapsulation by making our instance variables private. So I type here private string name, and private int roll number, private int fee, like this. And the second point was by making our getters and setters public. First of all, I type here setters. I type here public. You can also make the constructor, but for this video I'm going to skip this and go to the setters. I type here public void set name string name. This dot name equals to name, and then public void set roll number int roll number. This dot roll number is equal to roll number. And the third one is public void set fee and int fee. This dot fee equals to fee. Okay, so we have created our setters for our instance variables. Now in our third slide we have read that we can make our fields read only or write only. Now when we make the setters, the fields are only write only. We can only write our data to these fields. We cannot read data from them. We can only write them by using these setters. And when we make the getters, then we can only read data from the fields. We cannot write data to them. So in this way we can make our fields read only or write only. These are the benefits of the encapsulation. Now I make the getters for these. I type here public string get name and return the name. Now public get roll number and return roll number here. Okay, so public int here. Now the third one was public int get fee and return fee. Okay, so this is the encapsulation. We have wrapped our instance variables and the implementations like the getters and setters in one box, and this is what we call the encapsulation. We can achieve the encapsulation by making our instance variables private and our getters and setters public so that we can access the values. So this is what we call the encapsulation. I hope you understand, and the benefits are, you can say, we can make our fields read only or write only, and definitely we have control over the fields in this class. So I hope you understand. If you feel any problem, then you can ask me a question definitely. So that's it for this video. I will see you in next video. Welcome back to this course of Java. Today in this video we are going to discuss about the composition. Now composition in Java is the design technique to implement has a relationship in our class. We can use Java inheritance or composition in Java for code reuse. Now in composition we must have a relationship has a, means we have two classes, those two classes must have a relationship between them, and we can reuse our code through inheritance or composition. We know about the inheritance, and for this video we will discuss about the composition only. Now these are some important points about the composition that you have to keep in your mind, that composition must has a relationship. We have code reuse, we can reuse our code in composition. Now the composition is implemented using the instance variables, and we hide the visibility to the client classes. These are the 4 important points in the composition, and we will discuss about all these 4 points in our NetBeans when we will create our code. Then you will understand that how these 4 points are implemented in composition. Now look at this figure. The blue box, you can let this is a car, and the black box inside the car is the engine. We know that a car must have an engine. Now engine is a separate class, and car color and car gears are the instance variables of the class car. An engine and a car has a relationship between them. Engine is the part of the car. engine is a different object and car is also object, but engine is the part of the car, so we can see that they has a relationship between them. So let's create our program that implements the composition, and we also have to follow the 4 points that we have discussed before. So let's create a program. And now here you can see that I have a class with the name composition and I have other class with the name engine. In the same package is composition, we have two Java classes, engine and the composition. So first of all, I go to my engine class and going to type here some instance variables. Now I am going to create some instance variable in this class. So I type here private int car power and private string transmission, and you can say okay. So now I am going to create the getters and setters for this class. I right click and click on the insert code and click on the getter and setters also. Okay, so in engine class we have two instance variables and the getters and setters for them. Now I come back to my composition class. I am going to create a class here with the name class car, and in this class I am going to create instance variables. I type here private string car color and private int car gears. Okay, and now I am going to create the object of the engine class here. I type here engine e equals to new engine. Okay, now I am going to create a constructor here. I type here car and you can say string car color int car gears. Now in our engine class we have car power and transmission. Okay, spelling is wrong here. S also here. S. Okay, so integer car power and transmission. Integer car power and string transmission. Okay, so and inside the body of the constructor I type here e dot set car power and e dot set transmission, and then this dot car color is equal to car color and this dot car gears is equal to car gears. Okay, so now I have created the constructor for the class car. You can see I have car color, car gears, car power and transmission. And now I am going to create the getters for the car color and car gears. So I type here string get car color and return car color and int get car gears and return car gears. Okay, then I am going to create the getter for the car transmission. I type here public int get car transmission and return e dot get car transmission. Okay, so I change return type to string here. Also I make these getters public here, public, and then okay, now the last getter should be get car power and return e dot get car power. Okay, now I go to my main function and type here, you can say car C1 equals to new car, and in the constructor, first of all, I type the color. I type here black, then I have to type the gears, you can say 5, then power should be 500, and then transmission to manual. Okay, now if I type here C1 dot, then now I can access the 4 getters here: get color, get gears, get power, get transmission. I select the get power here and print it on the screen like system.out.print ln. And now if I run this program, you will see 500 on the screen. Now we have created the program for the composition. Before this code, we have discussed about the 4 points. The first point has a relationship. Now definitely car has a relationship with the engine. Engine is also a separate object and car is also an object. But engine is also the part of the car, so we can say that engine has a relationship with the car. Now the second point is the code reuse. For example, we have another class like truck. Now truck has also an engine, so we can use this engine class also there. We are reusing our engine class. So in this way, we can reuse our code. Now the third point was we implement it through the instance variables. And you can see that we have definitely implement our code through the instance variables like you can see in our code. And the fourth point was hiding the visibility. Now you can see that when we create this thing and we access the members of the other class, now the class engine is hid from the real world. We have just created the class of the car and we can use our engine also there. So also in this way we are hiding the visibility from the real world. I hope you understand about the compositions and also understand the 4 points about the composition that we have discussed in our slide. I hope you understand about the composition. If you feel any problem, then don't hesitate to ask me a question. I will definitely help you. So that's it for this video. I will see you in next video. Hello and welcome back to this course. Today we are going to discuss about the static keyword. The static keyword is mainly used in Java for memory management. It is a keyword that are used for share the some variables or methods of a given class. Now when you create a static variable in your class, then that variable allocates the memory only one time when you run that program. So in this way, static keyword is used for the memory management. So we can use our static keyword with variables that we also call the class variables. We can use the static keyword with our methods. We call that methods the class methods. We can use the static keyword with the block. We are going to discuss about the block in this video. And at the end, we can also use the static keyword with the nested classes. Nested classes means the class within a class. We have not yet discussed about the nested classes, but shortly we are going to discuss about the nested classes, and we have a better concept about the static nested classes in the nested classes video basically. And what are the advantages of using the static keyword? The static variable allocates memory only once in the class area at the time of the class loading. As I have explained before, that the static variable allocates the memory only once when you start your program. And using the static variable, we make our program more efficient. How we can make our program more efficient? Let's discuss an example that where it is used. Suppose we want to store record of all students of any school. In this case, student ID is unique for every student, but the school name is common for all. When we create a static variable as school name, then only once memory is allocated, otherwise it allocates a memory space each time for every student. Now I will explain this example. For example, we are creating the management system for a school, and we know that there are thousands of students in that school, and every student have a different roll number, different you can say name, etc. like that, but the name of school is same for every student. So what we do in the class of student, we make the school name variable static, so that the static variable which is the school name allocates the memory only once. In this way, we are not wasting our memory, we are saving our memory, because the name of the school is allocate its memory only once. So that's why we use the static keyword in most of the times for the memory saving. Now look at its syntax. First of all, public static name. This is the class variable. You can say the static variable. We use the static keyword before the name of the variable, and we make that variable static. And to make our function or method static, we use the static keyword like public static void function name, and we use the static before the return type, and in this way we can make our variable and function static. So let's create our program in our NetBeans to use static keyword with variable, method, block, and inner classes. And now for example, I am going to create a class here like class student, and here I am going to create some instance variables like string name and int roll number, and at the end the name of the school. You can say I make these variables private first, private, and this is also private. We always have to follow the best practices whenever we write our program. So now I'm going to type here private static string school name. Okay, so now we have two instance variables and one class variables, which is the static variable. I type here static class variable. Okay, now I'm going to create the constructor for this class. So I type here student, and I just type here, you can say string name and int roll number, and you can say that this dot name equals to name, and this dot roll number equals to the roll number. Okay, now you may got a question that why we are not initializing the school name in the constructor. So whenever we create the object of the class, the constructor is called. We know that. But before this code, we have learned that the static variable is single and is created once for all the class, like school name. So this is not a good practice. We can definitely initialize it in our constructor, but we will also have to follow the best practices of programming. So that's why we are not going to initialize our static variable in the constructor. We are going to use the initialization block. As we have discussed in our slide, that we can use the static with the variable, method, and the block. So now we are going to use the block, which is going to initialize the static variable. So I type here static, then I start the block. This is what we call the static block or initialization block. I can type here school name equals to, you can say like that, allied. So in this way we can initialize our static variables. We have used the static with our variable, and we have used static with the initialization block. Now we are going to make the function static. I am not going to create the getters and setters. You can definitely write here the getters and setters. To save the time, I am not going to write here getters and setters. I type here public static void, and the name is information, and in this method I am going to type a single statement, system dot out dot println, and you can say that this school is the biggest in this city, like that. This you can say. We have to understand this static right now. Okay, so we have used the static with our variable, we have used the static with the initialization block, we use static with our methods. So I think I have to create the getters and setters. So I create them with the code import. So I right click and click on the insert code and getters. Create the getters for all these. I create the setters here. So I click on the insert code setters. I'm not going to create the setter for the school name and generate. Okay, so now we also have the setters and the getters. Now if I go to the main function, I'm going to create a I'm going to create the object of the class student. So I type here student s is equal to new student John. You can say the roll number is like 300 for an instance. Okay. And now if I type here s dot, you can see that I can access all the getters and the setters for the student class, but I have also created the static method in my class with the name information. If I type here you can say information like this, and if I run this program now, you can see this school is the biggest school in the city. But this is not the good practice to call the static method. You can see here accessing static method information. What is the best way to call the static method is by using the class name. So I move it and type here student dot. You can see I can access the information as well as the get static school name. And the get static school name is basically also static. Here you can see here I can access all the static members of the class after the class name like this. You can see information. And now if I run this program, you will see the same message, but this is a good practice right now. In our very first program, the first program to print hello world on the screen, we have discussed about the system.out, and there I told you that system is the class and out is the static member of that class. So I hope you understand now that how static works. Now you may got a question that the school name is also static here. So why we are not able to access this system.school name here? Because this class variable is private right now, and we cannot access the private member outside the class. If I change it to public like here, and now if you go to the main function and type here student dot, now I can also access the school name. So in this way you can access all the static members of this class basically. So I hope you understand about the how static keyword is used and why we use this static keyword. We are also going to use our static keyword in our final project, where we have to access the account number basically of the user from our main class, and we can access that through the static keyword basically. So I hope you understand. We have also read about the inner classes in our slides. So how we can create an inner static class. Inner static class means creating the static class inside a class. We cannot create the outer class static. Like if I type here static, I cannot create that. This causes an error on the screen. Okay, static is not allowed here. So we can only use, if I type here public static like that, you can see an error. Static is not allowed here basically. So I move inside the body of the class. I'm going to create an inner class here. I type here class, you can say John for an instance. And now this is the inner class. You can say this is the inner class of the student class. Now I can also make this class public, private, protected. You can say like that. You can also make this class private here. And for this, and you can also make that class static like this. So we can also make our inner class static. So I hope you understand about this static keyword, that how it is used and where it is used. And okay, so one more thing here, we can also write more than one static blocks. Like I type here again static, I can write another static block here, and again I can initialize my static variables like this. I type here allied2 for example. So in this way you can write multiple static blocks in your program, and this time the value of allied school name will be allied2 because this static block is replacing this static block. So I hope you understand the static keyword. At the end I summarize that static keyword is used for the memory management, and we can also use the static keyword whenever we want to call the member just after the class name. You can see that the main method, like public static void main, the main function is also static here, because if the main function is not static, then first of all JVM basically Java has to create the instance, and with the help of that instance we have to access the main function. But this is not a good approach. That's why make our main function static, so that we can use this main function without creating the instance of any class. So I hope you understand. So that's it for this video. I will see you in next video. Hello and welcome back to this course. Today in this video we are going to discuss about the final keyword. Now final keyword can be used with the variables, method and the classes. Now variable may be an instance variable, local variable or static variable. First of all, final variable. When a variable is declared with the final keyword, its value cannot be modified. It is just like constant. Means once we created a variable, we can only initialize the variable once. To have a better understanding about the final variable, let's create our dummy program in our NetBeans. So here first of all I am going to create a class with the name demo, for example, and I am going to create a variable here like private string name. We know that this is a instance variable, and when I add final keyword with that, then this variable becomes the final instance variable. If I type here final, now this variable has become the final instance variable. You have an error there. A variable may not initialize in default constructor. It is saying that you must have to initialize this value. We initialize the variable in some time. Now we have created the final instance variable, and if I add static before it like this, now this variable has become the static final variable of the class. And if I create a dummy method here, I type here void dummy for an instance, and in this method I am going to declare a variable here like int a. Now we know that this is a local variable, and when I add final before it, final int a, now this variable has become the final local variable, that we can only assign value to a once, we cannot assign it again and again. Now we have an error that we must have to initialize it. Now we can initialize the final variable in three ways. First of all, we can initialize it when we have declared it, like I type here Java. The first way is this: we can initialize it with the, you can say it can initialize when it is declared. And the second way is using the constructor. You can type here demo, and inside the constructor you type here name equals to, for example, Java, like this. Now you have an error, we have to move the static from here. Now we can initialize the final variable at the time of declaration inside the constructor, and we can also initialize our final variable by using the initialization block. I type here initialization block, and in this block I am going to type here name equals to Java, like this. Okay, so now I remove this constructor from here like this. You can assign the values in three different ways: at the time of initialization, in the constructor, or in the initialization block. If this variable is static, like here it is static, now you have to type here static, and you can initialize the static final variable here. Okay, so this is the final variable, and now we have the final method. The final method cannot be overridden, means we cannot override the final method. And final class, it cannot be extended, means we cannot apply the inheritance, and we cannot extend the final class or cannot create the child class of the final class. So let's create our program for the final method and the final class in our NetBeans. So here I am going to create one more class here like class, you can say test, and now in this class I am going to create a method here. I type here public final void test, and in this method I am going to type a just single statement system.out print ln, and you can say here test. Okay, so now this method is final, and if I extend this class here like extends test, and I type here public void test, you get an error here. Now what is the error? Error is we cannot override the method in this class because that method is final, so we cannot override the method once we create it final. So I hope you understand that how final keyword works in the variables and the methods. Okay, so now I am going to remove this line, and now I am going to make this test class final. I type here final. As I type here final, I got an error. Cannot inherit from the final test. It means that once the class is created final, we cannot create the child class of that class, or we cannot apply the inheritance there. So in this way, final keyword works with the variable, methods and the classes. I hope you understand. So you may got a question that why we use the final keyword. For example, you are dealing with a program in which you have to maintain a value constant. You create a final variable and give him the value. Then that value will just act like a constant. It means that its value cannot be changed, and it is a final variable, and we can only initialize this variable once. So that variable will act as a constant there. And there are many other scenarios in which we can use the final keyword. So I hope you understand about the final keyword. That's it for this video. I will see you in next video. Hello and welcome back to this course. Today in this video we are going to discuss about this keyword and super keyword. First of all, this keyword. Keyword this in Java is a reference variable that refers to the current object. It is used to refer current class instance variable. For example, we have a method in the class, and in the parameter of the class we have a variable a, and there is an instance variable in the class that is also a. So how you can differentiate between them? To differentiate between them, we use this keyword. We will discuss about it in our NetBeans. Now, super keyword. Super keyword is used to call the constructor, methods and property of the parent class. You may also use super keyword in subclasses when you want to invoke a method from the parent class which you have overridden in the subclass. Now, for example, you have two classes, class A and class B. Now, class B is the child class of the A, means class A is the superclass. For example, you want to access the members of the superclass, so you type the super dot member of the superclass. So with the help of the super keyword, you can also invoke method from the parent class that you have overridden in the subclass. So let's discuss about this keyword and super keyword in our NetBeans. So first of all, here I am going to create a class A, and I create a instance variable here, string name, and I initialize it with John. Okay, so I create another class B, that extends A, and I also create a variable here with the name string name equals to Peter. And now I am going to create a method here, void display, and type a statement here, system.out.println name. And when I create a object of class B in the main function, I type here b1 equals to new b, and call b1 dot display. And now when I run this program, you will see Peter on the screen. Peter is present in the child class. Now if I want to access this variable from the parent class, then I type here super dot name, means go to its super class, which is A, and access its instance variable name. And now if I run this program, you will see John on the screen, because this time this is accessing the super class instance variable. So in this way we use the super keyword to access the members of the parent class. Now let's discuss about this keyword. So first of all, here I am going to create a class with the name test, and in the class I am going to create one instance variable, string name. And now I am going to create the constructor here, that is parameterized constructor that has string name. Now I have an instance variable name, and also in the parameter of the function I have one variable that is name. So how I differentiate between them? I type here name equals to name, and this thing does not make any sense here. So I differentiate it like this dot name means the name instance variable which is present in this class, and this time this is the instance variable in the class, so this dot name is pointing to this variable, and this is the value that we get from the parameters. And now I am going to create another method here that is string get name return name. And now if I create object of the class test here, test t equals to new test, and I pass John in the constructor, and I call t dot get name, and I am going to print it on the screen. So I type here system dot out dot print ln, and now if I run this program, you will see John on the screen. So in this way we can use this keyword to differentiate between the variables. I hope you understand about this keyword and the super keyword in this video. So that's it for this video. I will see you in next video.